All right, so we are going to solve equations just like we did yesterday. This is still section 1.1. It's just day 2 of it. We're dealing with equations with fractions in them. Okay? Fractions are no fun unless we're comfortable using them or using our calculator to deal with them. Remember, no phones on our desks and our laps. Make sure everything's put away while we're taking notes. You can get it back out as soon as we're done. So the very first thing I want to look at is I want to look at my equation. I've got 1/5 m equals 1/60 m plus 1. Now, we do not have to deal with this with the fractions. And it's much easier anytime we have an equation that we are trying to solve to get rid of our fractions. And we can do that because whatever we do to one side of an equation, as long as we do exactly the same thing to the other side, it's still an equivalent equation. It just changes the way it looks. To do that, we're going to have to get a common denominator, because if you look at my two fractions, I have two different numbers, don't I? 5 and I have 60. My goal is to get rid of both the 5 and the 60. The one issue that some people have here with determining their common denominator is they always want to go to the smallest number, okay? The smallest number is not going to get rid of every denominator. You want to keep it as small as possible, but it has to be at least the size of the larger denominator. So what's my larger denominator up here? 60, right? So my common denominator, in order to get rid of that 60, is going to have to at least be 60, if not higher. So what I do is I always look at the bigger denominator, and then I look at the other one, and I say, okay, does that other denominator divide evenly into the bigger one? Does 5 divide evenly into 60? It does. So what we're going to do is we're going to use our common denominator. I like to write it down, not necessarily so much for these, but when we get into a couple a little bit later with some more difficult ones, I like to write down what I'm using as my common denominator, and we're going to use 60, okay? That is the biggest denominator, and it is also 5 divides into it evenly. And what we're going to do is we're going to multiply every piece of this equation by that 60. Now, one thing I want to talk about is, I'm going to use this as an example right here. When we talk about terms in an equation, a lot of people get confused with that. Terms are separated by plus signs, minus signs, and equal signs. So if I'm looking at this up here, do you guys want to guess how many terms there are? Separated by plus and minus signs. 1, 2. They're like terms right now, but we just want to count how many of them there are. There's 1, 2, 3, 4, 5, right? All of those are separate terms. So if I were to multiply this equation, I would have to multiply every single term. Does that make sense? So what we're going to do is we're going to take this equation right here, and we are going to multiply every piece of it by 60. So I'm going to take and I'm going to put 60 next to every term in this equation, even the one without a fraction. There are 3 terms, the 1/5 m, the 1/60 m, and the 1. They're separated, terms are separated by plus signs, minus signs, and equal signs. I'm going to show you 2 different ways to do this with the fractions. One of them works as long as there are no variables involved. The other one works either way, even if there are variables. So there's one thing we can do here before we revert to the calculator, is I'm looking at my denominator. My first denominator is 5. How many times does 5 divide evenly into 60? 12. So what happens is when we're multiplying these, that 5 actually just cancels out or turns to 1, and that 60 is going to turn to how many times 5 goes into it, which is 12, right? Then we're going to take and we're going to multiply that 12 times the 1 and times the m. 12 times 1 times m is just 12m. Now, I also want to show you how you can do that in the calculator if that confuses you. Sometimes when we throw in some more numbers, those fractions just tend to confuse us. So I want you to look on your calculator. It depends on which calculator you have. If you're using one like mine, you're going to have that button there. That's your fraction key, okay? Some calculators might have a button that looks like this. Some calculators might. It just really depends on your calculator, okay? So I might have to come around and individually show you how to do it. But for example, if you're using one like mine, even though this one's pink, the ones up there are exactly the same. What I want to do is I want to hit 60 on my calculator. Okay. And then we're going to hit times. And we're going to enter the fraction 1/5. And how you do that is you hit the numerator first. So I'm going to hit 1. And then I'm going to hit my fraction key, the little ABC. And you'll notice it puts like a little backwards L. And then we're going to hit the denominator, 5. And then we hit equals, and it will tell us what we discover up there, which is what? 12, right? Anybody have a different calculator that needs to help you show? And then times. And whenever you have a fraction, put it in parentheses. And you do 1 divided by 5. So see how it comes there? You do it like that, right? Anybody else need help? It's 60 times. And then numerator 1. And then fraction 2. And then fraction 2. Okay, if you can't do it in your calculator, let me know. I'll say, go ahead and multiply the 1/60 times 60 for me. Okay. So you want to do 60 times, and then hit the fraction key, and then you can do the power Okay, that makes sense. Anybody else need help with the calculator? Okay, hit 60, and then times, and then you're going to enter your fraction. Hit your numerator 1, your fraction key, and then your denominator 5. Very good. All right, if I do 60 times 1/60th, or asking yourself a different question, how many times does 60 go into 60? Once, so that one cancels. That turns to 1. We multiply, and that just gives us 1m. And then we can't forget, even though that's not a fraction, it still has to be multiplied to keep my equation the same. So 1 times 60 is going to give me 60. Now we have an equation with no fractions that we can continue to solve. You can get fractions as answers, okay? But we've gotten rid of the fractions to help ourselves solve this one a little bit easier. We're going to take and we are going to subtract our m over. That is going to give me 11m equals 60. I'm going to divide through by 11. Does 11 go into 60 evenly? No. Do they have anything in common that I could reduce it by? A 2 or a 3 or a 4 or anything like that? No. So I can leave it. If you want to give me a decimal, you can. You can also just leave it like that. You don't need to change it to a mixed number. You can leave it exactly as it is on the paper. If you give me the decimal, let me see. It would be 5.45 repeating. You'd have to make sure you write it as a repeating decimal. Anybody have any questions? All right, I'm going to ask you a couple of questions, and I'm going to let you try to work on this one. This one looks a little bit different because where's our variable? At the top. Does that mean it's any different than the first one? No, those m's out to the side technically would be at the top if we wanted to put it as one fraction. The first thing I want you to do is I want you to look at your two denominators, and I want you to determine what you think your LCD should be. Again, one way to start is look at the bigger one. And then ask yourself, does the smaller one divide evenly into that bigger one? If it does, then you can just use that bigger denominator as your common and multiply everything in your equation through by it. Does 7 divide evenly into 63? Yes, so I would use 63 as my least common denominator. And I would go through and multiply everything out. If you're using your calculators can't do variables. However, What's in front of that first x in that x over 7? What number's in front of it? A 1. So you can just do 60 times 1 over 7, and then you'll just put an x with whatever answer the calculator gives. Same thing. You can do 63 times 2 over 3. I'm sorry, 2 over 63, and then stick an x with your answer. The other way, if you're not using your calculator, is to ask this. How many times does 7 go into 63 evenly? 9. So that 7 disappears, that 9 or 63 turns to a 9, and then we multiply 9 times x, which gives us 9x, which if you did in your calculator 63 times 1/7, you should still get what? 9. Keep going. If I do 63 times 2 over 63 in my calculator, or 63 goes into 63 one time, 1 times 2x is just 2x. Did you guys get 2 when you did 63 times 2 over 63? Okay. And then the 4 has to be multiplied by 63 as well, and that's going to give me 252. Okay. Now we have an equation with no fractions that we can continue to solve. We're going to take and subtract our 2x over. That is going to give me 7x equals 252. And I divide through and I get x equals, what is that? 36? Okay, thank you. Anyone have any questions? Kind of get the idea? Alrighty. Somebody say something? Yes. It probably wouldn't hurt unless you can tell what they are. Then, or just use. Oh, yeah, that might be an issue. Or either just use one of these, whatever, if you want to verify. All right, I want you to try both of those. Okay, everybody. Go away. So my LCD is going to be 24, and I'm going to multiply every piece by that 24. 24 times 1/3, or 3 goes into 24 8 times. 8 times 1 times p should give you 8p there at the first part, right? 24 times 3 is not a fraction, so nothing disappears. We just multiply 24 times 3, and that gives me 72. And then over here on this last fraction, 24 times 1/24 just gives me 1, and that is just 1p. Okay, so we end up with 8p equals 72 minus p, or minus 1p if you want to put a 1 in front of it. Does that look good? All right, and then we're going to take and we're going to add p to the other side to get my terms together. That gives me 9p equals 72. And so therefore p is going to equal 8. So far so good. All right, now number 4 is a little bit longer.
So I somehow did it with 3. I think I messed it up, but then I got 8.
Let me come look at it in just a second. That way I can kind of see what happened. With 4, we've got 3 fractions and 3 different denominators. The same method works, though. Look at the bigger one. Do the other 2 divide evenly into that one? If they do, then you can use that one as the common denominator. In this case, 42 is my larger one. 3 divides into 42, and so does 7. So we can use 42 as our LCD. And I'm going to multiply each piece by 42. And this is when, especially when these other fractions have numbers in front of them, or I'm sorry, in the top, it makes it easier to use the calculator. If you're not using the calculator, or if you were doing it the way that I told you the other way, this is how you would do it. You would ask, looking at that denominator, how many times does 3 go into 42 evenly? 14, I believe. And then we would take that 14 and we would multiply it by that 5y, which is going to be the same result as what you would get if you do in your calculator, 42 times the fraction 5 over 3. What did y'all get? 70. Well, guess what 14 times 5 is? 70, right? Then we're going to multiply 42 times 2y, no fraction to cancel, so we just multiply and we get 84y. On this next one, 42 times 1 over 42, those cancel, and that just leaves me with 1y. And then 42 times that last fraction, 5 over 7. You can do that in the calculator. I'm going to say 7 goes into 42 6 times. 6 times that 5 should give me a 30. Did you all get 30 when you did 42 times 5 over 7? Okay. Anybody not understand anything right now? All right, I notice I've got 3 y's here. 2 of them are on the same side. So before I start moving anything from left to right, I'm going to combine those two. 70 minus 84 gives me negative 14y. And then now I can take that single y and subtract it over with that 14. That gives me a negative 15y equals my 30. And divide through by negative 15 for the answer of y equals what? Negative 2. Are we kind of okay with those? Okay. We're going to keep doing the same thing, but I'm going to throw a little curveball. Everybody ready? Okay. Take a minute and write that one down. We're going to talk about what's different about it and how we have to approach it just a little differently. Still kind of the same process. So looking at this one, do you notice anything that's different about my fractions? There's a variable in the denominator. Every other one that we've done so far, our variables have been out to the side or in the numerator, which has no effect on my fraction, really. The key here is when you have variables in the denominator, what we have to do is we have to state our restrictions. Okay, and what I mean by that is, think about a fraction. We have a variable in the denominator. That means we're solving for something that we don't know. Think of a fraction. What is the only number that's not ever allowed to be in the bottom of a fraction? 0, right? So stating a restriction is stating the values of x that would make my denominators turn to 0. So I'm going to go back and look at my problem. And I'm going to start with this first denominator, 3x. I'm just focusing on the denominator. What I need to do is I need to figure out what number would I plug in for x that would make that entire denominator turn to 0. That's 3 times x, so what's the only thing I can multiply 3 by that makes it turn to 0? 0. So for my restriction, what I'm going to do is I'm going to say x cannot equal 0. Because if x were to be 0 when I solve this equation, I would not be able to use that as an answer because it would give me 0 in the bottom of my fraction, which is never ever allowed. Is everybody kind of okay with that? Somewhat? What about the other fraction that also has a variable in it? What's its denominator? It's just x, right? Sorry, throat's getting dry. That's just x. 1 times x or just x. What's the only number that would make that turn to 0? 0, okay, which is the restriction that we already have stated. Sometimes you might have to have 2 restrictions if there are 2 different denominators that give you 2 values that make it 0. So that's the very first thing we're going to do, is state a restriction. Then we're going to treat it exactly as we have been. We're going to figure out what our common denominator is. We just now have some variables that we have to include. So let me ask you this. Let's look at our denominators. I have 3x, I have 2, I have x, and I have 3. So let's think about the numerical parts. 2 and 3. What would a common denominator be for 2 and 3? 6, okay. But what else is also included in a couple of the denominators? An x, so my common denominator to be able to get rid of the entire fraction is going to be not just 6, but 6x, yep. So we're going to do our LCD of 6x. That is going to be large enough to make all of my fractions disappear. Again, the complicated thing here is your calculators can't do variables. However, we can deal with those a little separately. So I'm going to write times 6x to all of my terms here. Excuse me. The first thing I want you to do, I'm going to show you it on the board, is you're going to take in your calculator, we're multiplying 6x times 2 over 3x. The very first thing I want you to do is just forget about the variables for right now. I want you to just multiply 6 times 2/3. Okay, so in your calculator, do 6 times 2/3. What does that give us? Okay, now with the x's, do you notice when we are multiplying, we have an x at the bottom and an x at the top? What would those do to each other? Cancel out. Remember multiplying fractions, if I wanted to do this the long way, okay. 12 divided by 3 is 4, and those x's cancel. So we end up getting the same thing. Does that make sense? Okay, so with that first term, 6x times 2 over 3x is just going to leave me with 4. No variables, because those variables canceled out. As long as the x is in the bottom. Yeah. Next, we're multiplying 6 times 1/2. 6 times 1/2. Okay, or 6x. What is 6 times 1/2? 3. Does the x cancel out here? No, it does not. So that's going to give me 3x. The difference is this one has an x in the denominator. This one does not. So there's nothing to cancel the x's out. So it is going to stay with your result after you do the number part. Does that make a little bit of sense? What about if I multiply 6x times 4 over x? What is that going to give me? 24, because the x's will cancel there. And if I'm losing any of you, please stop me and ask questions. And then if I multiply 6x times 4 over 3, that's going to give me what? 8. Does the x cancel out there? No, it does not. There is only one x, no x down here. If you need to, you can always do it the old-fashioned way. 6x times 4 is 24x. 3 times 1 is 3. 24 divided by 3 is 8, and the x is still there. Okay, that's just kind of doing the work a little bit differently. Now we have a regular equation to solve. I got a 3x and an 8x on either side of that equation. I'm going to take and I'm going to subtract my 3x over to my 8x. And then I'm going to get that 5x by itself by subtracting my 24, and I'm running out of room, so I'm coming over here. That's going to give me negative 20 equals 5x. We divide through by 5, and x is going to equal negative 4. The one thing you have to do when there are variables in the denominator and you state a restriction, once you get an answer, just go back and ask yourself, did I get what I was not supposed to? I was not supposed to get 0. Did I get 0? No. So guess what my answer is? It's negative 4. Question: what would I say if I had gotten 0? But 0 doesn't work. What would I say? It can't solve it, right? There's no solution. Okay, so if you're working through these and on the questions, the variables in the denominator, when you have to state a restriction, if you get what you're not supposed to, then I just had a brain fart. You can't use that. Now, we don't really have a lot of time to do it. I just want to talk to you about this one real quick because you'll have a couple on your homework. Let me look at this, okay? My denominator is x plus 2, and that is the only denominator, correct? So what would x not be able to be? What plus 2 would turn to 0? Negative 2. So x cannot equal negative 2. I'm just briefly showing you this. I know it's kind of rushed, but I don't want to run out of time here. My LCD is going to be x plus 2.
homework have the same denominator?
Yes. When they're variabled like this, yeah, they'll have with something plus or minus. I didn't go to the depth of having something different. When you have binomials that are your LCDs, do you notice how you have an x plus 2 up here that we're multiplying by, if I would, and then you have an x plus 2 in the bottom? Those cancel each other out, and that just leaves you with the 3x. I don't know why I didn't write. And then here you've got that negative 4. That has to be multiplied by that entire x plus 2, so what do you think I should put that in? Parentheses. And then that last fraction, the x plus 2's cancel each other out, and you'd just be left with 2. Okay, so that's kind of, I'm not going to finish it, but I just kind of wanted to show you when you have binomials as LCDs, they cancel each other out. Okay? And the ones that we do in the homework, you do 38 through 58 even. It will be the same page as yesterday, page 90. If you want to take a picture, you're welcome to. It is on Canvas as well. We will go over these tomorrow and work out any questions that we may have. So do the best you can. I know we're kind of run out of room on that last one, or run out of time.